Okay, guys, so on lesson 3.3, applications of systems, a lot of these you're pretty much going to have to set up an equation, and then you're going to have to solve that equation, all right, based on what's going on. So here, Beatrice is weighing combinations of geometric solids. So you found that 4 cylinders and 5 prisms. When I hear and, I'm thinking plus right away, weighs 32 ounces. So all of those together equal 32 ounces. And that 1 cylinder and 8 prisms weighs 35 ounces. So again, that sounded just about the same. Write and solve a system equations to determine the weight. Okay, so when I solve this, first of all, I'm looking at the the question. It's asking me to determine the weight of a cylinder and a prism. So this will be cylinder weight, that'll be C. And then P will represent prism weight. Not prism. Okay. Now I'm going to go to here to get the first equation. It says we have 4 cylinders, right? So pretty much 4C, or 4 times C, and 5 prisms, or plus 5 prisms, is going to equal 32 ounces. So there's my first equation. And I pretty much do the same for the second part. 1 cylinder plus 8 prisms is going to equal 35 ounces. So now you got this equation in standard form, and so what you're going to need to do is solve for C and P, and then that's going to be your solutions. Okay, so you find that's going to be the weight. Okay, so to get you started, I need an opposite, right? So what I'm going to do is I'm going to change, I want these C's to be the same. So I'm going to change this 1 so that it's a -4. So that means I need to multiply times 4, -4 to make it the opposite. Okay, so what I'm going to do is multiply this out. I get -4C here, and then -4 times 8 is -32. And then -4 times 35, I think that's 140, so -140. And what I'm going to do is just bring this other equation down here just so it's easier to see and work with. Because like when I have like 3 equations on top of each other, it's kind of confusing. So I'm just going to bring this one down. So I'm kind of done with these, right? So now we're just working with these here. So now it's time to eliminate. So you're going to eliminate C, and then you're going to solve for P. So find P, and then take P and plug it back into one of these equations. So I'll probably take this equation, the 1C plus 8P equals 35. I'm going to take that, plug it in there, and then I'm going to find my C. Okay, and then that'll be my answer. Okay, now when you're talking about these like real life situations, you don't need to do a coordinate like that. That's only if it's just like a system of equations with X and Y, and there's no like details or anything like that as far as like what we're talking about. So just leave it like that, and that'll be your answer. Okay. All right. So now down here on this one, you got these 3 people, and what they're doing is they're going to the movies on one hot summer afternoon. The theater is having a summer special called 3 Go Free. They will get free movie tickets if they buy a large popcorn and a large soft drink. Okay, but they each have to buy one, right? So 3 people each have to buy a popcorn and a soft drink. So they take the deal. They go and spend a total of $250. So we're going to basically come up with some equations. All right. So, and then after that, later on, said the next week, so that'll probably be our second equation. They go back again, only this time they pay $8 for a ticket. That means each person paid $8, and they get a large soft drink. Okay, but they share one large bucket of popcorn. So 3 tickets for $8, 3 drinks because they each got one, but then only 1 popcorn in this case. So let's write this out. Okay, so the first situation again, they each buy a popcorn, right? So 3 popcorns, and notice I'm going to use P basically for popcorn. 3 large drinks, and I'm going to use D for drinks, and that all cost them $22.50. All right. The second situation, a little bit different. They go back, and this time they each pay $8. So 3 times 8 So they each paid $8, so 3 times 8, okay? And then they each get a large drink again. So now 3 times D. And then they all share just one popcorn. All right, so all of that together equals 37.50. So this equation looks a little bit different than the first one, but we're gonna like simplify it to get it to look like that one and get it in standard form. So first let's simplify this 3 times 8. So that would be 24. And we want it to be in this kind of the same format. You notice in the first equation that I had P first and then D. So what I'm going to do is I'm going to put 1P before the D. I'm switching them. You can, I mean, it's the same thing. Okay. Now what I want to do is get this constant on that side because I only want variables in the left. Okay. So now my equation is 1P plus 3D equals 3750 minus 24, that's 1350. Okay, so there's my equations, there and there. Now, the next question said, did you write 2 equations or did you use another method? So you don't really need to answer that question because we already did. All right, so I'm gonna just use this space to solve just because, there's not a ton of room for you guys here. So I'll set up the equations here. Oops, sorry, not D, 3P plus 3D. And you'll notice here they're both in standard form, so guess what? Elimination, okay? All right, so your job, use elimination, and now solve those 2 equations. So guys, the biggest thing is understanding how to solve it, how to set up these equations, because all the steps are kind of the same after that once you get the equations set up. All right, so now your family plans to buy a new air conditioner. They can buy the super cool X1400 for $800. Ooh, cool. Or they can buy the efficient energy X2000 for $1,200. So both models will cool your home equally well, but the inefficient energy model is less expensive to operate. In other words, like how much it's going to cost you per month is less, but it does cost more up front. The super cool one, the first one, it's going to cost you $60 per month, but it's cheaper up front. So it's kind of like, which one do I buy? And then while the efficient energy X2000 costs $40 per month. So that first one costs more, but then costs less per month. Okay, so first we're going to write an equation to represent the cost of buying and operating the super cool. So we're just going to start with super cool. So normally we would like to use X and Y, but here we're going to use C and M. Okay, so remember the equation needs to represent the cost. So we're going to set it equal to the cost. Okay, so the cost of the super cool is first we start with how much did it cost you when you bought it? $800. And then how much is it going to cost you every month? $60 times however many months you use it, right? So 60 times the amount of months that you use it. And now we're basically going to set it up the same way for the energy efficient one over here. So it's C, cost of how much it costs, so $1,200, plus this one costs $40 per month. So times 40M. All right, so now the question is, how many months would your family have to use the energy efficient model to compensate for the additional cost of the original purchase? So what this means is if you bought the energy efficient model, it's going to cost you more in the beginning. But notice that you're paying less per month. So eventually, when you start adding up the costs over time, you're going to end up spending the same amount at some point. And the question is, when will that point happen? Okay, so for instance, just for example, guys, like let's say we want to know how much would you pay after 10 months, right? Well, I would take that 10 and plug it in here. So 10 times 600, 10 times 60 is 600. So after 10 months, it would cost you $1,400. And then over here, and you don't need to write this part in, this last thing. Okay, if it was 10 months here, that would be 1,200 plus 40 times 10, 400. So after 10 months, it's going to cost me a total of $1,600 here, $1,400 here. So it still costs me more even after 10 months. But at some point, this number is going to be lower than this number. And when will that be is the question, okay? So to figure that out, you are going to take both equations and set them equal because you want to know when they will be the same. So now here's your job. Solve for m. That's all you need to do. Okay, solve for m. Okay. So figure out when will the cost be the same. So solve this equation. All right, and then over here, figure in your family will only use the air conditioner only 4 months each year. Right? So you're going to figure out this amount of months, right? And then, but knowing that you're only going to use it 4 months each year, how many years is it going to take? Okay, well, that means that you're going to have to take the knowing the fact that you're only going to get 4 months per year. In other words, like after 1 year, you're going to use it for 4 months. After 2 years, you're going to use it for 8 months. After 3 years, you're going to use it for 12 months. After 4 years, you're going to use it for 16 months, and da 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 da. Right? So, how many years, knowing how many months it's going to take, will it take until you actually start to save money? Because summer is really the only time that we use the air conditioning. I mean, in San Diego, we probably use it way more, right? We're using it like more than half of the year. Okay, but in this coach situation, so basically, figure that out. How many years is it going to take? All right, next one. All right, so Estelle and Carlos are going to be hosting a party to buy 6. Where they're going to buy 6 total pies for the guests. Okay, 2 lemon meringue pies cost $3. Cost $3 less than 4 blueberry pies. 3 lemon meringue costs $9 more than 3 blueberries. How much does each pie cost? Okay, so we're going to use L for the lemon cost. B is going to represent our blueberry cost because they want to know how much is each pie cost. How much is lemon? How much is blueberry? All right, so let's go here. 2 lemon, 2L, cost $3 less than 4 blueberry pies. So in order to equal the cost of 4 blueberries, I would have to add $3 because this basically cost, it says 2 lemon meringue cost $3 less than 4 blueberries. So that means I would have to add $3 to get these to be equal. So there's my equation. Okay, now the next one says 3 lemon meringues cost $9 more than 3 blueberry pies. So in order for this to be the same as 3 blueberries, I would have to take away $9, subtract 9. Now, I want to solve this knowing that I've got 2 variables in each equation by putting them in standard form. Okay, in order to put in standard form, I need a variable on the left and this number on the right. So what I'm going to do kind of the shortcut. I'm going to take that and just switch it over there. So now it's 2L. And if I switch it, now it's minus 4B. And then I'm going to switch this over to the right. So now it's negative 3. Then I'll do the same thing here. Move this here. So now 3L minus 3B. And then move this here. So now that becomes plus 9. I just switched the sign. And now notice I've got 2 equations in standard form. Use elimination to solve them and figure out the cost of the lemon and the blueberry pie. Okay? All right, so now this one, very similar to the one we just did on the previous page. I want you guys to, and I'm sorry, on the previous lesson. Okay, so I'm going to go back to lesson 3.2. Actually, not lesson 3.2. We're going to go back to, we just did one like this. Here we go. This one down here. Okay, so we set these 2 equations equal to each other, and this one is very similar. So if you go back to lesson 3, 2, sorry, this is lesson 3.2. At the very end of the video, I go over how to solve a problem that's very much like that one. Okay, so go and check that out. So go to lesson 3.2. Go to the homework help video and look at the end of video. Okay. All right. So now this one, also I have shown this before when you have a square root and x on this side. And that is going to go all the way back to lesson 3.1. So if I go to lesson 3.1, kind of towards the end of the video, there's some problems that look just like that. Actually, I think it's in the beginning of the video. Oh yeah, here it is. It's problem 340. So if you kind of fast forward and look for this problem, 340 or 3, there's 2 examples that are just like that, okay? So that was lesson 3.1. So go to lesson 3.1, okay? Okay, so now on this one, I will kind of show you how to start this one up. Okay, now this, remember these are fractions, right? So on the bottom here, I want to get rid of the 4 and the 2. So what I'm going to start by doing is multiply that all the way across. I put 4 there, there, and there. Now, if you remember, when you multiply that denominator, they just cancel. So then you have 3x squared here. These cancel, so it just has 5x. But then here, that's not a 4, so it doesn't just cancel. So what I'm going to do is do 4 times 1, which is 4, and then over 2. So I divide that, and it equals 2. Okay, now I have the equation that has x squared, so that means I'm going to need to make it equal 0. So what I want to do is subtract this from this side and this from this side, or from both sides, I mean. So now I have 3x squared minus 5x minus 2. And now, guess what? I'm going to have to use the x and the box and solve. Okay, now remember, don't just stop there and write the factors. Now you need to take those factors and then figure out what is x equal to. Okay? All right, on this one, now right away I notice I'm going to have to multiply these together, and 2x times 2x, that's going to give me 4x squared. And even here, when I distribute that, that's going to be 4x squared. So I'm kind of thinking initially I'm probably going to have to equal 0. Okay? So let's kind of work it through. So here, distribute that, here and there. Okay, so here I'd probably bust out the box and multiply that out. Okay, so there I'll end up with 4x squared. Here I'll end up with 2x and minus 6x. Okay, so then minus 6x and 2x, that's going to be negative 4x. And then here it'll be minus 3. All right, so what I noticed initially is I got 4x squared. I want to bring everything over to this side, so let's start by subtracting 4x squared from 4x squared. And I'm like, wait a minute, that's going to cancel, and that's the same, so they'll both cancel. So then I don't have x squared anymore. So if I don't have x squared anymore, I'm no longer making this equal to 0. So now it's just a linear equation. Now I just need to solve for x. So go ahead and find x. Okay. All right, this last one here, standard form. So elimination. Okay, find the x and the y. Okay, and then it's asking you to do it first algebraically, and then where do these two graphs intersect? Okay, we'll use Desmos, and then you're going to graph your 2 lines somewhere on here, okay? And then you're going to figure out where they intersect. And Desmos will show you. You can just click on it right away and then create that little sketch here. And then explain the relationship between the two, okay? What's the relationship between this answer and where the graphs cross? Well, the point, I'll give you this one, the point of intersection is the solution. Kind of a, simple question, but that's what it is. Okay, sorry you guys couldn't see that. But the point of intersection is the solution. All right,